we got a table problem here. In our table problem, our A of H is, so a tank has a height of 10 feet. The area of the cross section of the tank of height H is given by a function A, where A of H is measured in square feet. So this is area of the tank in square feet. The function A is continuous and decreasing. Probably going to need the fact that it's decreasing and or continuous. Selected values of A of H are given in the table above. Use a left Riemann sum with the 3 subintervals indicated in the data in the table to approximate the volume of the tank, indicate the units. So if I look and I do 3 rectangles with a left Riemann sum, here and here and here would be my 3 rectangles. But my change in H here is 2, my change in H here is 3, and my change in H here is 5, which means I can't set this up as one problem. I'm going to have to do width times length plus width times length plus width times length, and my widths change. So I'm going to go ahead, and my width here is 2 feet. If I'm doing a left Riemann sum, here's my rectangle. This is the right side. This is the left side. So this is 50.3 feet squared plus 3 feet times 14.4 feet squared plus my width here is 5 feet times my length is going to be 6.5 feet squared. If you're having a problem figuring out units, always write them out. Width times length plus width times length plus width times length. Plug it in my calculator because this was a calculator problem, and I get 176.3 feet cubed. 1 point for the Riemann sum, 1 point for the approximation. It said indicate units of measure. So you got units for getting the units in A, C, and D for this one. Does the approximation overestimate or underestimate the volume in the tank? Explain your reasoning. Because your graph is decreasing, it doesn't matter if your graph is decreasing and concave up like a cup or decreasing and concave down like a frown. If you're doing a left approximation for this decreasing function, it's going to be an overestimate. So overestimate because A of H is decreasing and we used a left Riemann sum. Did I have to write that it was a left Riemann sum? Well, yes, because if it was a right Riemann sum, then it would have been a underestimate. So the area in square feet of a horizontal cross section of height H feet is modeled by the function given by F of H. So this is area. Based on the model, find the volume of the tank, indicate the units of measure. Guys, when I want to find volume, I integrate the area of the cross section. I don't have to figure out what it is. They gave it to me. And what is the height of this thing? It is 0 to 10. So I'm going to integrate from 0 to 10, 50.3 e to the 0.2h plus h dh. And this is calculator. Please, 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 please do not just write down the answer if you're not trying these ahead of time. Make sure that you can plug these into your calculator. So this is 101.325,338. Again, it says indicate units of measure. I always find it's best to underline that so I don't forget. So volume equals 101.325, and your volume is still feet cubed. In part D, water is pumped into the tank. When the height, this is making me think no find when the height of the water is 5 feet, the height is increasing at a rate of, I know something, use the model from part C to find the rate at which the volume, so I've been given a rate and trying to find a rate, so this is no. Find when the height of the water is 5 feet, when h equals 5 feet, the height is increasing at a rate of a derivative of height with respect to time. It's increasing, so it's positive 0.26 feet per minute. And I'm going to try and find the volume, the derivative of volume, v dt. Indicate units of measure. If I'm trying to find a derivative of volume, that's going to be feet cubed per minute. But let's go ahead and work it out. Our equation, it says using the model from part C. So our volume is equal to the integral from 0 to some h, because we're going to plug in h is 5 feet, of 50.3 e to the 0.2h plus h dh. No find and when you always get from your problem, you have to have an equation that has your no and your find in it. So I have an equation that has h and v. And then I always take a derivative. For a no find when, I always take a derivative with respect to t. Sorry. This is going to give me that dv dt equals first fundamental theorem of calculus. When you take a derivative of an integral, your original function pops out. So this is 50.3 e to the 0.2h plus h. The difference is I'm taking a derivative of h with respect to t. I can't forget that implicit part, which is always in a no find when or related rates, and I'm going to multiply this by dh dt. So then my last step is to sub in. So dv dt equals 50.3 e to the 0.2 times 5 plus 5. Now, if you are using the 89, you have to make sure that this bottom, that you put it in parentheses, or you're not going to get the right answer. If you're using your 84, you can use the fraction button. But because this is a binomial in the bottom, you have to use parentheses. The unit for this was, because it is area is feet squared times, then multiplying it by this dh dt, which is 0.26 feet per minute. So my dv dt is going to equal 1.694 feet cubed per minute. Thanks for watching tables.